Today's video will be looking at 7.5 and we will be concentrating on graphing square root and cube root functions. So let's go ahead and start with something that we know. We want to find the inverse of each function and then sketch the graph of the function and its inverse. So if we look at number 1, we've got y equals x squared. If we have y equals x squared, we know that's a parabola that has a vertex at 0, 0 with a normal shape. So y equals x squared is going to look something like that, and that's going to be our original function. And we want to find the inverse, so we switch our x and our y, and then we solve for y. So y is equal to plus or minus the square root of x. You can either plot points, or we know that the inverse is reflecting over the line y equals x, and if I reflect that graph over that line, the inverse is that parabola going to the right. Now we have a plus or minus, so if I were to plug in 1, the square root of 1 would be 1 or negative 1 because of the plus or minus sign. The square root of 4 would be plus or minus 2, so giving me both of those mirrored points. We've got y equals x to the third power. Again, hopefully you remember what this graph looks like. There are no changes to the graph, so it's going to look like that. It's got that center at 0, 0. If we want to find the inverse, we switch that x and that y. We cube root, so y is going to be equal to the cube root of x. There is no plus or minus here because we don't have an even root. And again, we remember that this is just a reflection over our line y equals x. So when I reflect that line, if I plug in values, we get that that graph has been turned to the right. So we see that the inverse of x squared is the square root of x. The inverse of x cubed is the cube root of x. And today we're going to concentrate on graphing that square root of x and the cube root of x, which are just those inverses of graphs that you are familiar with. So we're going to start by graphing square roots. We're going to use the table of values to graph y equals the square root of x. If I take the square root of a negative 1, we get not real. If it's not real, it's not going to show up on our graph. The square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So we plot our points 0, 0, 1, 1, 4, 2, and 9, 3. Hopefully you realize that y equals the square root of x is not what we found in number 1. It is only the top half of the parabola. Because we do not have y equals plus or minus the square root of x, we're going to only have half of the parabola turned to the side. So now I want you to pull out your calculators, and in your calculator, I want you to graph y equals 2 times the square root of x, y equals 1/2 times the square root of x, y equals a negative 3 times the square root of x, and y equals a negative x. And then I want you to add all of those graphs to all those lines to your graph, and let's see how that number is going to affect it. So go ahead and press pause, get your calculator out, and graph them. I do want you to use the table of values so that you have an accurate portrayal of where the new graphs are going to be. Alright, you should now have all of your graphs done. We did the y equals the square root of x together. You could have done this in the calculator, you could have just plugged them in. If we are dealing with the square root of x, I'm going to deal with perfect squares. So those are the points I'm going to plot. The square root of 1 is just 1 times 2, so that point is at 1, 2. This next perfect square is 4. The square root of 4 is 2, but multiplied by 2, that point is now at 4, 4. This plug in 9 for x, the square root of 9 is 3, 3 times 2 is 6. That's how I got those 3 points for y equals 2 times the square root of x. When you plot these points for your homework, for your notes, for your quizzes, for your tests, you do have to have points plotted on your graph. Then we had 1/2. Again, use those perfect squares. If I have 1, the square root of 1 is just 1/2. The square root of 4 is 2. Half of 2 is going to be 4. 9, the square root of 9 is 3. Half of 3 is 1/2. So you do have that 1.5 there and 1/2 there. Now we have y equals a negative root x. When we add that negative, all it does is it's going to reflect that over. Because when I plug in 1, I still get 1, but now because of the negative, it's a negative 1. The square root of 4 is 2, but now it's negative 2. The square root of 9 is still 3, but now we're at a negative 3. And last, we've got a negative 3 root x. Square root of 1 is 1 times negative 3, so we're at 1, negative 3. Square root of 4 is 2. 2 times negative 3 is at negative 6. Square root of 9 is 3 times negative 3. We're at a negative 9. So we want to look at how does that a value, and the a value is the number that is being multiplied by the square root of x, how is that going to affect your graph? A is going to determine how stretched or how compressed the graph is. And you are used to this value from when you had parabolas. But the square root of x is the inverse of a parabola. Therefore, the rules are going to be inverse as well. Generally, if we have y equals x squared, if the value was bigger than 1, it was narrow. If it was a fraction, it was wide. If it was 1, it was normal. That's all going to be jumbled up now. So now the larger the number, so if it's greater than 1, instead of making it more narrow, it's going to make it more stretched out. Remember, it's going to be the opposite of what you think. Because we are dealing with the inverses, the rules are now inversed. The smaller the a value, so like those fractions, instead of making it wider, it's going to make it more compressed. And if it's negative, this rule is still going to be the same. It's going to reflect. Okay, so that's all for our square root graph. Now let's move on to our cube roots. Use the table so that we can graph the cube root of x. The cube root of a negative 8. That is possible since we have an odd root. The cube root of a negative 8 is negative 2. Cube root of a negative 1 is a negative 1. Cube root of 0 is 0. Cube root of 1 is 1. Cube root of 8 is 2. So we go ahead and plot these points. Remember, whenever you're not sure, you can plug it into your calculator and you can look at your table of values to get those points, or you can do it by hand algebraically, just plugging in those values. So we see again that the cube root graph is that inverse of x to the third power. We're going to do the same thing we did with the last one. I want you to plug these 4 equations into your calculator. Either plug in values or use your table of values to see how your graph is changing. So go ahead and press pause now. Alright, this time we see our new graphs. We weren't changing that a value. We weren't changing the number that was being multiplied by the root. We were changing the number inside and the number outside of the root. So we start with the cube root of x minus 4. When we look at that graph, we see that our graph has shifted to the right 4. We haven't changed the shape at all, we've just changed where the starting location is. And we always refer to that starting point. We don't have that vertex, but it's that pinnacle point where the graph is changing directions. Here it's going down, here it's going up. So that important point, changing directions, has been moved to the right 4 times. Then we've got the cube root of x plus 5. Our adding 5 is on the outside, and we see that that starting point has moved vertically up 5. Again, the shape has not changed. Then we've got the cube root of x plus 2. When we look at x plus 2, we see that that starting point has gone to the left 2. And last, the cube root of x minus 3 means that we've moved that starting point down 3 spots. So if we have a shift in the number inside of the radical, it's going to move our graph left and right, left or right. Can't move it left and right. And then the number outside is going to move our graph up and down. And this is true for all the other graphs that we have seen this year. Anytime something is inside, that is true for our parabolas, that was true for our hyperbolas. Inside is going to be a lateral shift, a horizontal shift. Outside shifts are going to be vertical. And if it's inside the grouping symbol, it's going to move the opposite direction of what we see. So this positive 2 is actually going to move our graph left 2. And then the vertical shifts on the outside are exactly what you see. So up 5 means that or positive 5 means that we're going to actually go up 5. Now these rules that we just discussed are true for all square roots and all cube roots. So even though we talked about the a value, when we looked at the square root, these a value rules are going to apply to cube root graphs as well. And the cube root properties that we talked about, the number inside and outside, are going to apply to square roots as well. Okay, so let's go ahead and put this all together. Turn on over to the back page. We have those general form equations. Y equals a times the square root of x minus h plus k. And the only difference is, instead of the square root, we have the cube root. A is going to determine, for both of them, their shape and their orientation. For their shape, it is either going to be stretched or compressed. For orientation, if it's negative, it's going to be reflected over the x-axis. And again, that's true for both the square root and the cube root. And we have that hk that is coming up again, which we've seen vertex form of a parabola in. That hk is going to shift h units horizontally. So that's our lateral or horizontal shift. And k units vertically. As we just finished discussing, if it's inside, it's horizontal and it's the opposite of what you see. If it's outside, it is vertical and it's exactly what you see. So we have a couple graphs that we are going to do together. When we look at our first graph, we've got y equals the square root of x plus 2 minus 4. As soon as you see your graph, think about, you have two options, either a square root or a cube root. In this case, we have a square root graph, so we know it's going to look like a parabola, turned to its side, but only half of the graph. When I look at the inside part right here, x plus 2, that's telling me that I'm moving my starting point left 2. When I see the negative 4, that tells me that I'm moving my starting point down 4. Normally our graph starts at 0, 0, but we went left 2 and down 4. So that is our new starting point. Because our a value is still a 1, that means that we are going to have a normal shape. So we are going to have, going up by 1 there, a point at 2, negative 2, a point at 7, negative 1. And don't forget to utilize your resources. You have a calculator with you. You can always use a calculator on your quizzes and tests. Plug that equation into your calculator and get points. Double check in your calculator that it looks the way you expected it to look. But be careful when you're plugging this into your calculator, make sure that that x plus 2 is in parentheses and the minus 4 is not underneath that radical. So now we have to consider the domain and range. We know domain is referring to all possible x values and range is referring to all possible y values. Well, here the domain are possible x values. When I look at my graph, x values are moving left and right. The smallest x value I have is a negative 2, and then it continues on forever in the direction going right. Therefore, my domain is x is greater than or equal to a negative 2. If I'm looking at my range, I'm going up and down. What are all the possible y values? Well, my lowest y value I see on this graph here is at a negative 4. And then my graph continues forever going right and up. Therefore, y is greater than or equal to a negative 4. For number 2, we look and we see that we have a cube root because we know that 1/3 is the same thing as a cube root. If it makes you feel more comfortable, you could rewrite this in radical form. But we do know that fractional exponents and radicals, those are the same thing depending on how you are going to move between the forms. Just make sure that you move correctly. The x minus 3, that's inside our grouping symbol, so that means that we're moving our starting point right 3. The plus 4 means that we're moving our starting point up 4. And now our negative 2. The negative 2 means that it's going to be reflected, and normally that makes our graph more narrow, but we have the inverse now, so now it's going to be more spread out. Okay, so I want you to take all this information and see if you can graph your equation correctly. So go ahead and press pause. All right, make sure that you have good points on your graph. We moved our starting point from 0, 0. We went right 3, and we went up 4. So we see that our starting point is in the correct spot. And we said because it was a negative 2, it was going to be reflected. So instead of going like this, it has been reflected going the other direction. And the 2 has made it more stretched out or more spread out. So it's kind of got like a wider shape going on here. Our domain, if I'm looking at all possible x values, well, it's going forever left and forever right. There are no restrictions, so that's all real numbers. Range, this is forever going down and forever going up, so that is also all real numbers. It's kind of easy for your cube root graphs. It's always going to be all real numbers for both the domain and the range. Now we have our very last problem for our notes today. We've got y equals 1/2 times the square root of x minus 1. When we look at that equation, the x minus 1 tells us that we're going to move our starting point right 1. The 1/2 is going to make us see that our graph is more compressed. So we normally start at 0, 0, but we've moved our graph right 1. And we've made it more compressed. So we look at, if we plug in, again, plug in numbers. So we plug in 2. 2 minus 1 is 1. 1 times 1/2 gives us 1/2. The easiest thing I can tell you is to go to your calculator and look at your table of values and find good points that you can plot. So we see that when we plug in our numbers, our graph is more compressed. Our domain, possible x values, going left and right, our smallest x value is at 1, and it gets bigger. So x is greater than or equal to 1. Our range, we're looking at possible y values. Our smallest y value is at 0, and then it forever goes up. So y is greater than or equal to 0. Okay? So just remember your rules, and all of our rules apply for both square roots and cube roots. And we are all done for today.